All right, today we're going to determine the quadrant and angle terminates. So it's important you understand what it means to be in certain quadrants. So you have sine of 120. This is what we're doing first. What's the sine of 120? You know 120 is in quadrant 2. It's this angle right here. So what you do have to make sure is make sure your calculator is in degree mode. So go to mode in your calculator, which is right next to the second button. Go to the third line down and highlight degrees, okay, because we're putting sine of 120 degrees in there. So do sine of 120, so you hit the sine button and then 120. You don't have to do the degree symbol. And you do 0.8660 approximately. Cosine is negative 0.5 and tangent is negative 1.7. That was close. No. 1.7321. Generally, when we do this, we go to the 10,000ths place. So notice that sine is positive and cosine and tangent are both negative. So that's important to understand and to recognize. To do the cosecant of 120, to put this in your calculator, there's no cosecant button, so you have to put 1 divided by the sine of 120 because it is the reciprocal. And same deal for this one, 1 over the cosine of 120 and 1 over the tangent of 120. So try those out and let's see what you get for those answers. So you'll notice that if the tangent was negative over here, the cotangent is also negative, and cosine is negative, and so is the secant. Sine is positive, so is the cosecant. So these are your answers to 4 decimal places. So that just kind of shows that there's certain times or certain quadrants that you're in where like sine is positive, and there's certain quadrants where cosine is positive and tangent and so on. So which quadrant is the cosine of an angle positive? Well, that's this one right here. Cosine is always positive in quadrants 1 and 4. So there's a lot more kind of that goes along with this, but you have to understand it at an almost very basic level. So you have to understand that all trig functions are positive in quadrant 1. This one, it's only sine and it's reciprocal cosecant. This one, it's tangent and cotangent. So in quadrant 1. And in quadrant 4, cosine and its reciprocal secant. So we remember that as all students take calculus, you will find other ways to remember it from your peers. I will not tell you those. So which quadrant is the cosine of an angle positive? Well, that's 1 and 4. Since cosine is positive, so is its reciprocal secant. Excuse me. Secant is also positive. So which quadrant is the tangent of an angle positive? Well, that's quadrants 1 and 3. Since tangent is positive, so is its reciprocal. So this may seem weird, but you just have to, it's something you have to memorize. So we know we enjoy doing that, memorizing things. But this is a unit that takes a lot of that. So we use this particular information. So remember, we make this ASTC. We make this to remember the primary trig ratio. So it's all sine, tangent, and cosine. And then we remember their reciprocals go along with them. So if the sine is negative 5 over 13, and it terminates in quadrant 3, so we know we're over here in quadrant 3, find all 6 trig ratios. Okay, so this is what I do. I write sine, cosine, tangent, and it's theta, so I'm doing theta. So this is just what we did before. Hold on, I can't talk and write that easily. Okay, so I put the sign right next to its reciprocals because they go together. You just flip them, right? So if I'm in quadrant 3, I know that only tangent and cotangent are positive. So what I do is I put a sign there. Okay, these are both positive. The rest are negative. After that, it's just what we did before. So that means that sine is opposite over hypotenuse. So this is my theta. So opposite is 5. Hypotenuse is 13. And to figure that out, I have to do the Pythagorean theorem. So the 13 is the hypotenuse, so it's by itself. 5 squared plus we don't know squared, and it does turn out to be 12. So this is 12. So this is theta, this is the opposite, this is the hypotenuse, and this is the adjacent. And then I just go through it. So I know the sine is opposite, well, it's already there. They already told you that one. So you already know that this one is 13 over 5. You just flip it. Cosine is adjacent, so I need the 12. And then flip it. Tangent is opposite over adjacent, and then cotangent is the flip. So that's all you have to do. The big deal, the big difference today is the fact that we have to deal with the fact that if I'm in a different quadrant, I'm going to have different things being negative. So with this one, if an angle goes through the point, 3, -4, find all 6 trig ratios. So what we have to do, we're like, okay, let's find that point. So it's 3, -4. So it's right about here. So what I do is I draw a right triangle with the x-axis. So draw a right triangle with the x-axis. Always the x-axis. Doesn't really work if you don't. I'm going to zoom in, I guess, because my drawing, it really stinks. Okay, so that's the x-axis. So the right angle is always on the x-axis, and the other point is your origin. Okay, so our 3 points are the point that they gave us, the point on the x-axis, and the origin. That's always your 3 points for your triangle. So no matter where you are, you draw your line to the x-axis and do that. So I could draw, if the point was over here somewhere, I could draw a point there. I would draw down to the x-axis and to the origin. And that's how I do it. So then we have to find our lengths of our sides. So to do this, this is 3 right here. It's pretty obvious. And the height right here is 4. This height right here is 4 because that's the distance. This point is 3, -4. So the distance is 4. So then this one right here, if we do our Pythagorean theorem, is 5. So you can do the Pythagorean theorem yourself to figure that out. All right, so our angle comes from the origin. So there's that. So this is where our angle is that we're going to be discussing. So those are a few things that you have to remember when you're doing these. Drawing that triangle can be a little tricky sometimes. So you always draw it with the x-axis, and our theta is always at the origin. So theta at origin. Yay! And now we have to find our 6 trig ratios. So we know our theta is, we know this is opposite, we know this is hypotenuse, and then we know this is adjacent. And now we just have to do the sine, cosine, tangent, and then cosecant, secant, and cotangent. So the first thing I always do once I start this is I do my signs, the positive and negative. I am in quadrant 4, so if we recall, let's pick this color, this is A, S, T, C. So cosine is positive, and secant is positive. Everything else is negative. Okay, so that's one thing you just have to remember there. And now we just do our OATC stuff and be happy about it. So sine of theta is opposite over hypotenuse, so we flip it. Cosine is adjacent over hypotenuse and flipped. Tangent is opposite over adjacent. There we go. And we have our angles. Well, our cosine, sine, whatever, the ratios. All right, so take a second and try this one, and then I'll throw out the answers for you and see how it goes. Okay, so here's this one. I have the cotangent is 2 over 3. So it's adjacent over opposite. So adjacent over opposite. Use the Pythagorean theorem to find the radical 13. And then I have to find sine, cosine, and tangent. I know it's in quadrant 2. So I know that only sine is positive. Just those two are positive. These guys are all negative. And then I just do my O over A and all that other stuff. So we have to do a little more with the radical in the denominator when we get to school. But this is basically how you do it. Good luck.